So let's get started for today's afternoon session. Again, mostly focused on emotion and mostly from my lab's online presentation and also finally Masumi lab's computational work by Haruka. All right, please go ahead, Vera and Mario.
Alrighty, I will share my screen. Beautiful. We're all good with what we can see?
Yes.
Okay, lovely. All right. Hi, my name is Bella, and I will be sharing the progress of my ongoing research of my honours year. My focus has been on exploring the relationship between colour experience and depressive symptomatology. It has been well documented that colour perception is vital to the visual experience, facilitating memory recall, food identification, attention, signalling, and the transmission of information. Within a healthy population, research conducted by members in our lab has established the structural and experiential equivalence of colour experience across the visual field. By briefly presenting solid coloured circles in various central and peripheral positions on a screen and asking participants to rate their dissimilarity of the colours, this study found colour experience to be largely invariant across the visual field when the stimuli were magnified as a function of retinal eccentricity. The schematic of this task can be viewed here, but will be presented in a little bit more detail a little later. As stated, my study aims to investigate the relationship between colour dissimilarity perception and depressive symptomatology. This research is motivated by both anecdotal accounts and empirical evidence, which suggest a significant correlation between depression and the perception of colour and the world as grey, cloudy, and drab. This self-report study by Barrick in 2002 suggested that impaired colour sensitivity may be a state or trait marker of depression, but conceded that further studies validating this association with objective measures were necessary to demonstrate the strength and consistency of this relationship. Depressive episodes have also been associated with poorer visual contrast and colour discrimination in central vision. Employing the Farnsworth-Munsell 100 hue test, a recent study found that individuals experiencing a moderate to severe depressive episode, meaning a score of 14 or above on the Beck's depression inventory, had a significantly impaired capability to discriminate and arrange colours sequentially, underperforming healthy controls in nearly all chromatic pairings. While studying depressed individuals, researchers have also discovered variations in the central and peripheral visual systems. However, these differences have primarily been examined in relation to attentional bias. For instance, in a study conducted by de Zorzi, emotionally charged pictures were presented to participants in both central and peripheral vision. It was found that depressed individuals exhibited a central attentional bias, particularly when the stimuli had a negative emotional valence. Here, we can see that depressed samples had opposite patterns of reactivity towards unpleasant pictures compared to the healthy controls. Significantly, the depressed sample manifested a response bias towards unpleasant pictures in their central vision compared to when the stimuli were presented at 24 degrees into their periphery. Whilst past research has identified differences in colour discrimination and perception within a depressed population, observed variations between their central and peripheral visual systems have been focused on attentional bias rather than colour experience. Therefore, there is a significant gap in our understanding when it comes to investigating the role of colour discrimination within this context. Whilst depressive symptoms have been correlated with a grey perception of colour and poor colour discrimination, it is also unknown whether the demonstrated impact of depression on colour perception is experienced equally across the visual field. Therefore, our study aims to utilise a novel colour dissimilarity paradigm, which has been previously established by our lab to investigate the association between depressive symptoms and colour similarity relationships. Additionally, we will examine the equivalence of colour experience across the visual field in a depressed population. Our first hypothesis is that the increased severity of depressive symptoms will be associated with an overall duller perception of colour. This proposed difference in colour perception is depicted here on the slide. This hypothesis is anticipated to be supported by lower mean and lower variance values of color dissimilarity judgment scores across the entire visual field. Our second hypothesis is that depression is associated with a duller perception of color at the periphery compared to central vision, indicating an unequal color experience across the visual field. This hypothesis is expected to be supported by lower mean and lower variance values of color dissimilarity judgment scores for stimuli presented at the periphery compared to the center. Our participants will be recruited via Pavlovia, an online platform on their personal computer. The two key variables of perceived color dissimilarity and depressive symptomatology will then be measured using a color dissimilarity task and Beck's depression inventory known as the BDI. The online color dissimilarity rating task utilized in this study was adapted from a recent research project conducted within our lab. Within the task, a stimulus set of 93 colors ranging in hue, saturation, and brightness will be presented as solid colored circles on a gray background at various locations on a screen. A brief demonstration of the task can be viewed here. As you can see, two randomized stimuli will be presented for 250 milliseconds in two possible configurations, either center to center or periphery to periphery. Participants are then asked to judge the dissimilarity of the two colors using a discrete scale ranging from -4, indicating least similar, to +4, indicating most similar. A lower score therefore corresponds to a decreased perceived similarity between the two colors. Depressive symptomatology will be assessed by a self-report using the BDI. The BDI consists of 21 statements related to depressive symptoms, and participants are asked to rate their statements based on their own experiences across their previous 2 weeks. Their total score is then calculated by a summation of all of their responses. To date, our pilot experiment has gathered data from 70 participants. However, during data analysis, we have excluded 13 participants due to failed catch scores and a double pass correlation below 0.5. Therefore, the final data set for analysis consists of 57 participants. The double pass paradigm allows us to measure the consistency of responses and is fulfilled by participants completing each color pair judgment twice for each eccentricity configuration. The graph on the left provides a visual representation of the color dissimilarity responses from a single participant. We can see from the green and the pink that for each color pair, the participants' responses in both rounds are predominantly the same or very similar, indicating a high level of consistency in their perception of color dissimilarity. And then, as we can see on the right, this particular participant, had a double pass correlation of 0.85. Only participants with a double pass correlation higher than 0.5 were included in the final analysis of the experiment. This selection criterion ensures that participants chosen for analysis demonstrate a significant level of consistency in their responses between the 2 rounds. Here we have 2 visualizations of the pilot BDI data. On the left side, we see the distribution of total scores representing the overall level of depressive symptoms. And on the right, we have the distribution of BDI groups, categorizing participants based on their scores. Total scores above 14 indicate a mild depressive episode, whereas scores of 20 and 30 or above correspond to moderate and severe levels, respectively. Here, we can see that there are currently no significant relationships between the participants' BDI scores and their double pass correlation. Preliminary analysis of the pilot data revealed no significant associations between BDI scores and the mean value of color dissimilarity judgment scores. Similarly, no significant associations were found between the BDI scores and the variance of color dissimilarity judgment scores. These two findings suggest that the first hypothesis, which proposed depression would be linked to an overall duller perception of colour, indicated by lower mean and lower variance of dissimilarity judgments, has so far not been supported. Before looking at the pilot data's response to the second hypothesis, it is important to note that the current version of the task is yet to calibrate the display to the participant's screen size, viewing distance, and angle of their peripheral blind spot. The eccentricity of the peripheral stimuli will also be expanded in the final version of the experiment. That said, the current version of the task did not find evidence to suggest the relationship between BDI scores and the mean colour dissimilarity judgments were moderated by central or peripheral position of the stimuli, as we can see here. Similarly, there is currently no evidence to suggest the relationship between BDI scores and variance of colour dissimilarity judgments are moderated by the stimuli position. As such, preliminary data analysis of our pilot data is consistent with an invariant colour experience across the visual field, irrespective of depression scores. To briefly touch on the significance of our project, this study aims to further our understanding of the relationship between colour perception and subjective psychological variability, bearing on fundamental questions about the phenomenology of depression. We hope to further understand to what degree depression is a disorder of conscious or subjective perception, and explore the nature of potential subjective perceptual deficits, and also question whether the self-reported grey or drab, cloudy experience of colour associated with depression is a result of attentional, phenomenological, or cognitive processes. Finally, our next steps are to expand the eccentricity of our perceptual stimuli to cover a wider range of the visual field and increase our participant sample size to enhance statistical power and generalizability of our findings. And I am sure that we will keep you updated. Thank you.
Thank you. Okay, is there any comments or, yeah?
I may have missed. I'm going to. Okay, it's hard to make myself clear.
Can you make the video turn on?
Yeah, I'm trying to see which one. Wait, which is any of them? Oh, here, no, here. I just have one.
That one, yeah.
Here. Hi, thanks for your talk. So I may have missed, but I wonder if you just look at the trials, including grayish colors, and maybe they show like increased similarity to gray. So every colors look more similar to gray. So like looking all the color and analyzing every all together might be kind of smudging or the hidden effect. So some similarity to gray or some similarity to like a cool color rather than warm color. This kind of analysis we are checking. Maybe.
Were you able to hear?
Yeah, I was able to hear. So sorry, was the question regarding like whether we should look at just to see if everything's closer to grey or closer to a blue, rather than the warm colours?
So an analysis per stimulus category could be potential way to see if there's some specific effect in certain color classes.
Yeah, absolutely. Errol, you could speak, but I would assume that in further analysis, we're going to create a matrix of the dissimilarity relationships between each colour. And so if participants did find like their colours to be more blue or more grey, I would assume that would come up in the matrix when we do create it.
Yeah, there's a lot of different subgroup or different kinds of analysis that we can do with this data set. The initial reasoning behind looking at just overall mean and variance is if the idea is if in like the general population, you have a certain set of dissimilarity values people report, whether it's red to green, blue to yellow, some shade of red to some shade of pink. If you're imagining that for a particular participant, everything looks grayer, then that has to ensure that their judgments become more similar to each other, because there's just a smaller range of judgments that they're going to make because it just everything looks gray. They might correct for that in terms of the range of dissimilarity responses they give, but then you would expect at least the variance of their responses to go down. So that's why we started off with just these really crude measures of like overall mean or overall variance, looking for that. But it's true that like they could definitely have other patterns of responses or restricted, like they only give grayer responses for stuff that's close to gray to begin with, rather than for primary colors or more saturated colors. So yeah, thanks for the advice. There's quite a few analyses we still plan on doing like that.
Thank you.
Yeah, this is still like, only the initial pilot experiment with 70 people. So even if we do the median split analysis, we have only like 30 subjects for the lower depression and the higher depression. And we probably need at least like 200 people or something to fill in all the similarity matrix in our design. So,
yeah, we don't have to do it in quite the same way as the standard matrix stuff. Like what I'm suggesting we could do even without filling in the entire matrix. As an example, we could pick colors and then look at proximate colors, or it can be done with an empty set. But it's true, it would definitely be easier if we had more data. Still impressive Bella's gotten all of this in only the first few months of her honors year. So it's not bad progress so far.
yeah, she just started this around the end of February, right?
Interesting.
Any other comments or questions? You are potentially going to do the similar experiment, but with the optimism bias, right? Reverse
case, and I plan to measure the difference between the high optimistic people and the low optimistic people is perception colorfulness is the using the binocular library and the
library.
Yeah, binocular library and if the beforehand see some image, the binocular library doing the binocular library, the perceptual bias is different from the depending on the colorfulness, I think. So I use this for calculate the difference between the people, but it's also in my case, we use this similarity
rating.
The similarity rating because it doesn't say about the perceptual bias is affected by the colorfulness, some darkness or something, some factor is affected. So it is difficult to say it is caused by the colorfulness. So it's in the same case. If the Qualia structure is not narrow, is it the colorfulness? The difference of colorfulness.
That's what we are kind of hypothesizing. That eventually, if we get the similarity matrix, full similarity matrix, the hope, or if this hypothesis is correct, then as I kind of predicted, that similarity rating around gray will concentrate around very similar rating, and then that should actually contract all this space into gray, and that will be very difficult to, for example, align between the normal people's color to this one. So that's the kind of the idea. Or if the blueness is also, I don't know whether feeling of a blue expands or shrinks the experience of blue.
Yeah.
I don't know, what's the prediction?
I was thinking of Picasso, who had a blue era when he was depressed. All his drawings became. So I wonder if the actually different blues may become more dissimilar because they had like a higher resolution around blue, while other colors are shrinking.
Have you encountered something like that, Vera? Like blueness and also depression.
Well, I've heard of the Picasso's like blue era. So yeah, I mean, I think like blue and gray are often like brought up as that's the like prevailing color when like during a depressive episode. More gray than blue, but the Picasso era is a really good example. I could look more into that as well.
In terms of subjective reports, like I know you mentioned one during your introduction, but as far as I'm aware, you didn't find a huge number of previous subjective report studies in depressed patients. Is that correct?
No, yeah, no, not heaps, not a lot. A lot of the studies looking at the visual systems or even like perceptual changes in depression have been focused on attention, not color perception. Yeah, there's only a handful.
This is a comment of my own, but for everyone else, like what I find quite interesting about this study is like it may well turn out that we find that there are absolutely no differences in these experiential reports between people with higher BDI scores, so higher depression scores, and the healthy participants. And then that ends up being really fascinating too, because it just shows that like people report these feelings of blueness and grayness and like other metaphors and these attentional changes, but the experiences themselves stay the same. It's like, you'd think somebody would have checked this before, like whether the phenomenology is changed or not in like literally the most common mental disorder in the world. But it might not have been the case at all before this.
Yeah, that's also I was thinking. So if what if we in the end, really provide a strong evidence to suggest that the depressed people actually, have a same, Qualia structure in terms of the similarity. One possibility is that this depressed people's report is mostly based on the memory, right? Memory of the color, or I don't know, previous memory of some kind of colorful experience is now faded. But currently, if they see the same thing, then they might feel the same way or something like that.
Well, you could make analogies to the cultural studies that have been run, where if you look at different cultures and you get people to do perception and discrimination tests, you see that people have pretty much the same performance no matter their cultural background, but you do get cultural influence on like categorization and memory of colors. So like maybe there's a similar thing here where like it affects the memory, but not the actual discrimination or reports.
Yeah, that's what I was also thinking.
I would imagine maybe person really could be more sensitive to change in depression. So it's people in depression probably wouldn't go out wearing vivid red and things. Like it's like choice of color and preference and being comfortable around certain colors rather than the perception or its similarity, maybe more behavioral change that you may expect.
I mean that's also possible, and it's probably interesting to look into, and we can probably do that. But still, it remains mysterious that people primarily first subjectively report that the world is faded, right, in terms of color, and that needs to be explained. Their subjective description is about the quality of color fading. And if they are mistaken their preference, that's in itself interesting in itself, but I think that requires some kind of explanation. Is there any other comments or question? By the way, Bella, I wanted to actually ask some expert advice on this distribution of the DBI online participants. Can you show the slides again?
Yes, I can. 2 seconds. What slide did you want?
Histogram. DBI,
Oh, histogram, the histogram.
Is this more or less expected from the normal population BDI distribution? Would you say?
Vaguely remember two lumps actually.
Yeah, that's
So,
two
yeah,
lumps,
yeah,
right?
yeah.
Yeah. Oh, so this makes sense then.
But I record this basically only because you asked.
But if there is two lumps, then below 14, there's one around 9 or something. And there's another one between 20 to 30. So that seems to make sense. I wasn't sure actually if the online participants will have a similar level of the BDI distribution or whether this BDI. But is this the one that you shuffle the order, Bella?
Yep. Yeah, of the questions, yeah.
Yeah, well, we decided to shuffle the order. Otherwise, some people just reported 1, 1, 1, 1, 1 for everything. But then this looks reasonable then.
I think so, but I think with Google image search with BDI distribution.
Ah.
It would.
That's a good idea. Maybe Bella, you can check the BDI distribution on the Google image to see whether the distribution actually makes sense or not.
And also I've heard, this is without reference, but I've heard that BDI is not as sensitive to pick up range of depression in healthy population. So you may also consider some other measures. I can't think of something that is better for sure, but there could be some measure that is more sensitive to big range in non-clinical population.
I mean, the way to kind of publish this paper, one possibility is after you finish this online experiment, you write the paper as a registered report on the experiment 1 online, and then critical experiment 2 as a face-to-face experiment, but with the clinical population, the depression in collaboration, like Makiko or somebody has an access to this depressed people population, and then there, if it's just like face-to-face and then n equal 10, 20, maybe that's sufficient number or something. I think that would probably convince both, color psychophysicists and also, skeptics on the online population or online BDI measure in terms of the depression. The gold standard is clinically assess the depressed people, right? Usually.
Yeah, I think that would be most convincing.
Awesome. I'll stop sharing now.
Yep.
There you go.
Okay. Thanks a lot. If there's any other comments or questions.
No, all good.
Okay, good. Thank you.
Thank you. Thank you.
Let's go to next talk.